Moving on with our identities, we have what we call double angle identities. And the first one is that sine of 2 times theta is equal to 2 sine theta cos theta, and that cos 2 theta is equal to cos squared theta, take sine squared theta, or some other different forms of cos squared, 2 cos squared theta take 1, or 1 take 2 sine squared theta. So to explain what these mean, we'll do an example. So if I take, say, we're going to say theta equals pi on 3, therefore 2 theta is 2 pi on 3. So if I look at 2 sine pi on 3 cos pi on 3, what we're saying is that that will equal sine of 2 pi on 3. Now sine of pi on 3, if I just jump across my unit circle, pi on 3 is up top right, so sine is root 3 on 2, and cos is a half, so this will be 2 times root 3 on 2 times by half. So the 2's, the 2.5 will cancel, so we'll just get root 3 on 2 equals sine of 2 pi on 3. And if we look back to our unit circle, we can see that that checks out. So 2 pi on 3 is now top left, and its y coordinate is root 3 on 2. So that checks. Okay, now also tan, well, tan of 2 theta is 2 tan theta over 1 take tan squared theta. And we can actually show that that's true. So if we just go tan 2 theta equals sine 2 theta on cos 2 theta. So it's 2 sine theta cos theta all over cos squared theta take sine squared theta. And I can divide the top and the bottom by the same thing. If I do that, I won't change my fraction, and the same thing is going to be cos squared theta. So I'm going to lose a cos theta there, and it's going to leave me with 2 sine on cos, which is just tan, so it's going to leave me with 2 tan theta. And here it'll be cos squared on cos squared, take sine squared on cos squared. That cancels to 1, so it'll be 2 tan theta on 1 take tan squared theta. And that's what we get. So, how are we going to use this? Well, we can say if sine theta is equal to 4 on 5 and theta is less than pi, less than or equal to pi, but greater than or equal to pi on 2, find sine 2 theta and tan 2 theta. So in this case, we need cos theta to be able to find sine 2 theta. But what we know is if sine theta is equal to 4 on 5, then 4 on 5 squared plus cos squared is equal to 1, because sine squared plus cos squared equals 1. So then cos squared theta is 1 take 16 on 25. So then cos, if I just, well then cos squared is 9 on 25, and then if I square root that, I'll get 3 on 5. So cos theta is either plus or minus 3 on 5. Now, is it plus or is it minus? Because that will change our answer, depending on which one we use, and it matters because we were told where theta is. So theta is between pi on 2, so between straight up and between straight to the left. So in this region, cos is negative, so we can say that cos theta is minus 3 on 5. So once we got that, we can go sine of 2 theta. We know it's 2 times sine theta. Now sine theta was 4 on 5, and cos theta we just found is minus 3 on 5. So if we put that all together, we get minus 24 on 25. So 4 by 3 by 2 is 24, and 5 by 5 is 25. So sine theta is minus 24 on 25. Now tan 2 theta, well, for tan 2 theta, we're going to need tan theta. And we know that tan theta is sine theta on cos theta. So it's 4 on 5 on minus 3 on 5. When we have two fractions with the same denominator, we can just cancel the denominators, so it'll give us minus 4 on 3. So then tan 2 theta is 2 times tan theta, which we just found as minus 4 on 3, over 1 take tan squared theta, so minus 4 on 3 squared. So then we have 2 by minus 4 on 3, so it's minus 8 on 3, all over 1 take. Now, 4 on, when we square a negative number, we just get a positive number, so it'll be positive 16 on 9. Okay, so minus 8 on 3 and 1 take 16 on 9 gives me minus 7 on 9, and then if we work that through, we're going to get which equals 24 on 7. Okay, and there's the working out there on the left to show that equals 24 on 7. Okay, alright. Now, another question we can ask is if cos 2 theta equals 9 on 15, find sine theta. Or we might be asked to find cos theta. Now there's several options depending on what we want of what cos 2 theta is equal to. So if I go back up here, we see that this third one is the one we want because it has cos 2 theta in terms of sine theta only. So we can say that 9 on 15 is equal to cos 2 theta, which is equal to 1 take 2 sine squared theta. So 1 take 2 sine squared theta is 9 on 15. So if I move it to the other side, I'm going to subtract 1, so it'll be 2 sine squared theta, or minus 2 sine squared theta, because 9 on 15 take 1. And then if I divide through by minus, I'll get 2 sine squared theta is 1 take 9 on 15, which is 6 on 15, or 2 on 5. Okay, and then I can go through and divide by 2, so I get sine squared theta is 2 on 5 divided by 2, which is going to give us sine squared theta is equal to 1 on 5. So then sine theta is equal to plus or minus the square root of 1 on 5, which is plus or minus 1 on root 5. Okay, now is it positive or is it negative? Well, we don't know because we're not told where theta is, but if it was added to the question, that theta is between 3 pi on 2 and pi, then if we go to my unit circle, then we can see we're in this region, so bottom left region or bottom left quadrant where sine is negative, and so we can say therefore sine theta is minus 1 on root 5, or minus root 5 on 5, whichever you prefer. Okay, now it can also help us factorize expressions. So we can, another question can be simplify 5 sine theta cos theta. Now the issue with this is that sine 2 theta is 2 sine theta cos theta. Now we don't have a 2 there, but it's not as like we've got a multiple of 2 there either. So we need to somehow get a 2 there. And if I go 5 on 2 times 2, well 5 on 2 times 2 is just 5. And I can write that now as 2 sine theta cos theta. So all of this becomes sine 2 theta. So this equals 5 on 2 sine 2 theta. The other one we could look at simplifying is 4 cos squared 3 beta, take 2. Okay, now this doesn't quite look like any of the forms we've got, but we know that 2 cos squared take 1 is cos 2 theta, so I can take out a common factor of 2 here, leaving me with 2 cos squared 3 beta take 1. So that's the form we need. And then it's going to be 2 outside of cos, and it's 2 theta, so it'll be 2 times 3 beta. It's 2 times whatever angle in there is in there. So that's 2 cos of 6 beta. We can also be asked to solve an equation like solve sine 2x plus sine x equals 0. Now that looks a little hard to work with, but let's do what we know. So we know what sine 2x equals. It equals 2 sine x cos x plus sine x equals 0. And because we're equaling 0, if I can get this into separate factors, I can say each of them should equal 0 using the null factor law. So if I take out sine x as a common factor, I'll be left with 2 cos x plus 1 equals 0. So I can say that sine x equals 0. So x equals, well, the options are sine x equals 0. So if I go to my unit circle, it's 0 at 0 and pi and 2 pi. So x equals 0, pi and 2 pi for x between 2 pi and 0. If it was a different domain, I'd have to include more values. Also, 2 cos x plus 1 equals 0 means that cos x is equal to minus a half. So x equals, and we're just going to look at the first revolution. So cos being minus a half, so I come along my x-axis, I see minus a half on the left here. I go up and I find one of the angles is 2 pi on 3 and the other angle is 4 pi on 3. So 4 pi on 3 and 2 pi on 3 for x between 2 pi and 0. Okay, so they're my solutions, and that's how we can use the double angle formulae in solutions. So questions that I want you to work on for next time are from 5G, and these will be on the Google site. Pretty sure it's 5G. Check the Google site because I may have got that wrong. And it's questions 2, 4, 6, 7, 10, just the final column of 10. And then 11 to 15. And all of these are really important, and especially 11 to 15 are necessary in preparing you for next year in using this.